The high pressure oil system has a leak. We've already determined it by doing our testing. Now to check for oil leaks, you're going to need to supply shop air to the high pressure oil system so we don't have to run the engine and we can listen for any leaks. The pressure can be supplied to the system through the port where the pressure sensor is installed. We can use a regulator to control the shop air so it's not too high. Here's an example of what we'd be cooking in if it was located here, and here is the pressure sensor down here on the fuel pump. We're going to remove this sensor in this particular case and install a fitting so we can adapt our shop air into it. Then we're going to connect our shop air in and control it with a pressure regulator. We could use nitrogen or CO2. Most people just use shop air. Make sure it's good and dry and clean of any debris. So we're going to supply shop air through a regulator so we don't have full pressure going. And we're going to take our scan tool and we're going to control the pressure regulator. We're going to go to 0 first to fully open it and drain all the oil from the system. Let the air flow through it a good long time, maybe up to 20 minutes if the engine's cold. And if you're taking this apart and doing this with the engine hot, you're a better man than I am. But after 2 or 3 minutes, you're going to command the IPR, the pressure regulator, to 80%, which is what's listed on our scan tool. You could go to 90. You should hear a reduction in the amount of air passing through the regulator. If you don't hear a change in the air, the pressure regulator isn't working or it has a control fault. Go fix the regulator. The problem is the regulator is not working. But if you have it working and you hear less air, then use a stethoscope to locate the leak. Some noise is always going to be heard around the valley. This is normal. The pressure regulator is always going to be sending air back into the reservoir. But noise near the back of the intake valley may indicate a cracked pipe or fitting, failed O-rings in one of the pipes, a failed snap-to-connect connector on the back of the high-pressure oil pressure pump. Air noise in the valve covers indicates leaking at the injector standpipes and D-plugs or O-rings on the fuel rails. Here's what we're talking about, looking at it visually. Back toward the back here, noise near the back of the intake valley may indicate a cracked pipe, failed O-ring, or a failed snap-to-connect connector on the high-pressure oil pump or to the branch tubes. We have a lot of places that can leak. All the places we point out here are possible leaks. We could be the discharge lines in the snap-to-connect, could be one of the high stand pipes, one of the injectors. You're going to have to go in and find it, and the only way to do is take it apart. Once we start taking it apart, make sure O-rings and fittings sit good and have no leaks. Check for any abrasions like we have here, where this pipe is worn down, you see here on the side. That's causing a leak in this particular case. When you put it back together, make sure that's not rubbing like that so that you don't have a repeat of this problem. Here's what it looked like when it was mounted in position. Again, you may have leaks in the system. You may have to take things apart to find them. Here's our famous snap-to-connect. Old style on the left, new style on the bottom right. If you have the old style, put in the new one. And the way you put it in is you disassemble it and put the new pieces in so that you get rid of the snap-to-connect connector and put in one that screws in so it stays in place. Here's some standpipes to look at. I want to get a close-up so I can show you what some of these look like. We're going to be looking at this check valve that keeps oil in there. Notice that one of the legs are broken off here. That little spring is the real size. We've magnified it here so you can see it. It's pretty small. Take a look at these O-rings. They're really in bad shape. Yes, it takes a long time to get here, but there's no other way to get here. We found these by looking at our high pressure. We could not achieve our 4,000 pounds in this particular case. So we knew we had some oil leaking or bad pump, and we came here and tried to find out which one. Like everything else from Ford, we've got the old, we got the new. Starting in early, we had a 1/2-inch drive to remove the standpipes. Then, midterm, we had a 10mm Allen. Then later on the newer 6.0s, we've got a 12mm Allen. So we're going to have to take these standpipes out of the common rail high-pressure oil delivery system. Here we have opened it up so you can see it. We've got the valve cover off, getting down where you can work on it. As you notice here, you're looking at where the standpipe would fit highlighted here. This is where these screw into the standpipe. Here's what it looks like. By the way, we have acoustic wave attenuators. These are made to reduce the waves that are acoustic waves, the sound waves that are created when we have injector pulses. Now you see the two, the front and the rear. port, that's where the standpipes are going to come in to this rail at the top. And this is where we take these out and find our bad O-rings. You've got the front port and the rear port. They're different. You should know that, but be aware of it. You should put back what you take out, obviously. Here's our two standpipes we're taking out, getting ready to remove them out of there so we can get in and work on the system. These are the anti-bleed back valves that can cause extended cranking. They go in the standpipe so that the standpipe doesn't drain all the oil back into the system. We want these to stay full of oil so when we start cranking, we have oil pressure already and we don't have to bleed out air that will take us a long time to fill up before we can get cranking. Now when you are done and you're ready to put this back together, you need to fill the common rails with oil. The new rails at the top, the old rails at the bottom. Wow, Ford with new and old. Isn't that surprising? Notice we only have one acoustic wave attenuator on the old style while we had two on the new style. Here's the two on the new style, one on each side to level things out. These are again going to hook our oil pressure right into our injector, tops of the injectors. So we've gotten the oil to our injectors and the fuel is coming in the middle. Now the injectors are ready to be mounted back in the rail and ready to start making sure we have fuel getting to our injectors, and we're going to control this oil pressure. We're going to get into details about controlling this oil pressure.